Okay, abnormal molar mass. That means till now we discussed one point, right? Using colligative properties, we can calculate molar mass of a non-volatile solute, right? Yes or no? By taking a fixed amount of non-volatile solute, then adding that to the given amount of solvent, that is known solvent, we can calculate molar mass of the non-volatile solute, right? Either by using relative lowering of vapor pressure, or by using elevation in boiling point, or by using diffraction in freezing point, or we can use osmotic pressure. ಅಲ್ವಾ ನಾವು ಆಲ್ರೆಡಿ ಒಂದು ಡೆರೈವೇಶನ್ ಮಾಡಿದ್ದೇವೆ ವಾಟ್ ಈಸ್ ದಿ ರಿಲೇಷನ್ ಬಿಟ್ವೀನ್ molar mass with the colligative properties. Okay, using that relation we can calculate molar mass of the unknown solute. Okay, then while calculating that molar mass, sometime, okay, for some solutes, okay, non-volatile solutes like bases, acids or salts, okay, clear? That is means if that solid substances are ionic, okay, if that solid substances are ionic, then we are facing some problems, okay. That is, we are calculating, or theoretically we are assuming 1 molar mass for the non-volatile solid. That means if you take sodium chloride, theoretical molar mass of sodium chloride is 58.5, right. But experimentally if you calculate that molar mass, we are getting half of that value. So experimentally calculated molar mass is not either that is lower than the theoretical value or that is higher than the theoretical value. Okay, that concept is called abnormal molar mass. Okay, the molar mass determined by colligative properties is found to be lower or higher than the normal molecular mass. Okay, normal molecular mass ginta experimentally ನೀವು calculate ಮಾಡಿದ molecular mass either that is lower or higher. Clear? Suppose if you take example, if molar mass is 40, that is theoretical, or normal is nothing but theoretical. Okay, theoretical. Okay, theoretical molar mass of the solid substance is 40. Okay, that is normal molar mass. But if you calculate molar mass of the substance by using colligative property, okay, colligative property, then that molar mass MB, either that is greater than 40 or MB less than 40, or nothing but that is either greater than normal molar mass or that is a lower than normal molar mass. Okay, then that molar mass is called abnormal molar mass. Okay, abnormal molar mass. Clear? There will be some change in the which one molar mass, experimentally calculated molar mass than the theoretical value. Okay, yes. Then we'll discuss what is the reason for this abnormal molar mass. Okay, ಈಗ ಡೆಫಿನೇಷನ್ ಅರ್ಥ ಆಯ್ತಲ್ಲ abnormal molar mass ಅಂದ್ರೆ ಏನಂತ. Okay, then we'll go for this one, what is the reason for the abnormal molar mass. Okay, this colligative properties, okay, we can use these colligative properties to calculate molar mass only when your solution is very dilute. Okay, your solution is very dilute. This is a condition you have to satisfy in order to calculate molar mass of the non-volatile solid using colligative property. First condition is you have to prepare very dilute solution. Okay, second condition is solute does not undergo any change. Okay, okay, if there is no change in this solute, okay, then we can use this property. Okay, first condition is you have to take a very dilute solution. Second condition is that solute does not undergo any change. Okay, this one is clear, right? A dilute solution. Okay, you have to prepare a very dilute solution. Then we'll discuss what is the meaning of there is no change in the solute. Okay, okay, now take NaCl. Okay, take NaCl. Okay, now if you take NaCl, that is 1 mole of NaCl. Okay, 1 mole of NaCl. Colligative properties are properties of a dilute solution which depends on the number of particles, right? Here we have 1 mole of NaCl, right? We have 1 mole of NaCl. Okay, theoretically we are assuming we have only 1 mole of NaCl, nothing but 6.023 into 10 to the power of 23 sodium chloride molecules. But if you add that into solution, since NaCl is an ionic solute, if you add that to water, that will dissociate to form 1 mole of Na plus 1 mole of Cl minus. 1 mole of Na plus 1 mole of Cl minus. Okay, theoretically, how many particles we have actually? How much? We have only 1 mole of NaCl. Okay, nothing but we have 6.023 into 10 to the power of 23 molecules, right? NaCl molecules. Okay, but once that undergo dissociation, nothing but NaCl will undergo dissociation to form 1 mole of Na plus and 1 mole of Cl minus. What is the number of particles here actually? 1 plus 1, we have 2 moles of particles. 2 moles of particles, right? We have 2 moles of particles, right? So now if you simply theoretically assume if we have 1 mole of NaCl, but practically we have 2 moles of particles, right? Theoretically we have only 1 moles of particles, but experimentally or practically we have 2 moles of particles. Clear? Now we can observe the difference if solid undergo dissociation. This in case of dissociation. In case of dissociation, that is the meaning of change. Okay, solid will undergo dissociation. Okay, if you take ionic solids like NaCl, that will undergo dissociation to form ions. Okay, if you take NaCl, we have 1 mole of NaCl, but if you prepare a solution of 1 mole of sodium chloride, that will undergo dissociation to form 1 mole of Na plus and 1 mole of Cl minus. For every 1 mole of solid particles, we have 2 moles of the particles, right? So initially we have 1 mole, that is theoretically. If it undergoes dissociation, we are getting 2 moles. Okay, so right, observed colligative property is twice the normal colligative property. Normal colligative property, right? In case of NaCl, observed colligative property is twice the normal colligative property. Observed means what? Experimentally calculated colligative property is twice the normal colligative property. Colligative property andre enu? Property which depends on the number of particles. Theoretically ನಿಮಗೆ ಎಷ್ಟು particles ಇರೋದು? Only 1 moles of particle, but experimentally we have 2 moles of the particles. Okay, so clearly observed colligative property is twice the normal colligative property. Okay, now we know molecular mass Mb is inversely proportional to colligative property. If you go for any formula, Mb equal to ನೋಡಿ colligative property ಎಲ್ಲ denominator ಅಲ್ಲಿ ಬರ್ತದೆ. Yes or no? ನೋಡಿ molecular relation between molecular mass and colligative property, go for that 4 formula. Okay, all the colligative properties are in the denominator. Yes or no? If you take this osmotic pressure, okay, osmotic pressure formula Mb equal to WBRT divided by pi V, pi L into denominator. In case of elevation boiling point, delta TB is in denominator. In case of diffraction in freezing point, that delta TF is in denominator. In case of relating lowering of vapor pressure also, PA0 minus PA divided by PA0 is in denominator. So clearly shows this molecular mass is inversely proportional to colligative property, right? Now just take example this one, that is we have osmotic pressure Mb equal to WBRT divided by pi V, right? WBRT divided by pi V. Okay, then what is this now? Equation number 1 is nothing but a theoretical molecular mass. right? Theoretical molecular mass, right? MB is, this equation number 1 is nothing but theoretical molecular mass. Okay. Now, according to this expression for sodium chloride, okay, calculated as observed colligative property is twice the theoretical value. So I can write pi equal to 2 pi, right? Pi equal to 2 pi. Okay. Now, here's MB equal to WB RT divided by pi equal to what now? Observed colligative property is twice the theoretical. Theoretically, we have pi. Then experimentally, that will become 2 pi into V. 2 pi into V, or we can write MB equal to WB, that is 1 by 2 into WB RT into pi V, right? MB equal to half of WB RT divided by pi V. What is WB RT divided by pi V? WB RT divided by pi V is nothing but a theoretically calculated molecular mass, right? Theoretically calculated molecular mass. Okay, what is this now? That is experimentally calculated molecular mass. Clearly you can observe, okay, experimentally calculated molecular mass is equal to half of theoretically calculated molecular mass. Yes or no? WB RT divided by pi V is nothing but theoretically calculated molecular mass. We have expression, right? Already expression kaltidire. For osmotic pressure, the relation between MB and pi is MB equal to WB RT divided by pi into V. This is nothing but theoretically calculated molar mass using colligative property osmotic pressure. Then we observe that for NaCl, okay, calculated that's observed colligative property is twice the which one theoretical colligative property. So pi equal to 2 pi. Observed colligative properties, that is twice. Okay, so MB equal to WB RT 2 pi into V. So if you simplify that one, you are getting MB equal to half of WB RT divided by pi V. Okay, what is this MB actually? Experimentally calculated molecular mass, nothing but observed molecular mass is equal to half of normal molecular mass, right? So if you calculate molecular mass of sodium chloride by using colligative property like osmotic pressure, okay, so then that observed which one molecular mass is half of the normal molecular mass. So this one is nothing but observed molecular mass is equal to half of normal molecular mass. Okay, observed molecular mass is half of normal molecular mass. Okay, the normal molecular mass sodium chloride is 58.5 ಇದೆ. Okay, if you calculate that by using osmotic pressure, you are getting half of 58.5. Clear? Yes, that is in account of dissociation. Okay, if you take ionic solids which undergoes dissociation, then calculated molecular mass, okay, that is observed molecular mass is always lower than the normal molecular mass. If any substance undergoes dissociation, then observed, that is experimentally calculated molar mass using colligative property is always lower than the normal molecular mass. Okay, ಅರ್ಥ ಆಯ್ತಲ್ಲ? ಕೊಲಿಗೇಟಿವ್ ಪ್ರಾಪರ್ಟಿಯನ್ನು ಯೂಸ್ ಮಾಡಿ, ಓಕೆ, ನೀವು ಮೊಲಿಕ್ಯುಲರ್ ಮಾಸ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿದ್ರೆ ಯಾವುದಕ್ಕೆ ಅಯಾನಿಕ್ ಸಾಲಿಡ್ಸ್ ಗಳಿಗೆ, ಓಕೆ, ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿದ ಎಕ್ಸ್ಪೆರಿಮೆಂಟಲಿ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿದ ಕೊಲಿಗೇಟಿವ್ ಪ್ರಾಪರ್ಟಿ ಇಸ್ ಆಲ್ವೇಸ್ ಲೋವರ್ ದನ್ ದಿ ಥಿಯರಿಟಿಕಲ್ molar mass. That is in case of dissociation. Okay, now clear, right, why molar mass of the solute is lower than the normal molar mass. Okay, next there is one condition, that is nothing but change in solid. Second condition is on account of association. On account of association. First case we discussed, if a solid undergoes dissociation, then calculated molar mass is always lower than the normal molar mass. Next, suppose take some solids, they will undergo association. Okay, normally non-polar, okay, solvent. If you take non-polar solvent like benzene, okay, non-polar solids like benzene, then you're preparing a solution of benzoic acid in benzene. Okay, this one is a solute. Okay, you're preparing a solution of benzoic acid in benzene. Okay, in this case, okay, there will be association of the molecule. Okay, what is the formula of benzoic acid? C6H5COOH, right? C6H5COOH. You are taking 1 mole of benzoic acid. Okay, then that will undergo dimerization. Dimerization andre, suppose if you are taking A and A particles, okay, ಇಲ್ಲಿ ಎಷ್ಟು ಪಾರ್ಟಿಕಲ್ ಉಂಟು? 2 particles, right? ಇಲ್ಲಿ 2 particles ಉಂಟು. If they undergo association, we are getting only 1 particle. You know, colligative properties, they are totally depends on the number of particles, right? Not on the nature. ಇಲ್ಲಿ ಇನಿಷಿಯಲಿ ಅಸೋಸಿಯೇಷನ್ ಆಗೋ ಮೊದಲು 2 ಪಾರ್ಟಿಕಲ್ ಉಂಟು, ಬಟ್ ಅಸೋಸಿಯೇಷನ್ ಆದ್ಮೇಲೆ ಓನ್ಲಿ 1 ಪಾರ್ಟಿಕಲ್ಸ್, right? That is the meaning of association. 2 particles ಇದ್ದದ್ದು 1 particle ಆಗುದು, or 1 particle ಇದ್ದದ್ದು, that means half, right? Here in this case, if you take 1 mole of benzoic acid, that will undergo dimerization to form C6H5COOH twice. Okay, that is half. Okay, 1 mole of benzoic acid, that will undergo dimerization to form half mole of benzoic acid. Illi 1 mole of particles ittu, illi baruvaga half moles of particles. Suppose if you take 2 mole of benzoic acid, illi 2 mole tagoli, you are taking 2 moles of benzoic acid. After dimerization, after association, you are getting 1 mole. Artha aitalla? If you take 4 moles of benzoic acid, after association, you are getting 2 moles of benzoic acid. So simply we are writing for each 1 mole of benzoic acid, okay, theoretically we have 1 mole of benzoic acid, but actually experimentally it is found that we have only half moles of benzoic acid. Okay, if you take 1 mole, experimentally we are getting only half moles of the benzoic acid due to dimerization, that is nothing but association of the benzoic acid molecules. Okay, so for each 1 mole of benzoic acid, we are getting only half moles of. Okay, then you know, Mb is inversely proportional to colligative property, right? Mb is inversely proportional to colligative property. Then you know, observed colligative property is equal to, or colligative property is half of the normal colligative property, right? Observed colligative property, this one, observed colligative property, right? That is a half of the normal colligative property, right? Observed estirudu nimage half, but actually theoretically ಎಷ್ಟು ಉಂಟು 1, right? So observed colligative property is half of the normal colligative property. Substitute that data here. Okay, take osmotic pressure, that is Mb equal to Wb RT divided by pi into V. Okay, that is one is nothing but theoretical or normal molar mass. Okay, then you know, Mb equal to Wb RT divided by, okay, observed colligative property 5, that is half of the normal. Normal is 5, half of the normal means what? 5 by 2. ಅರ್ಥ ಆಯ್ತಲ್ಲ? ನಾರ್ಮಲ್ ಎಷ್ಟಿರೋದು ನಿಮಗೆ 5 ಉಂಟು, ಆಸ್ಮೋಟಿಕ್ ಪ್ರೆಷರ್ 5, ಬಟ್ ಆಕ್ಚುಲಿ ಅಬ್ಸರ್ವ್ ಮಾಡಿದೆಷ್ಟು? by 2, half of the normal. 5 ಇದ್ರೆ half of that means what? 5 by 2 into V, 5 by 2 into V, nothing but in with the equation Mb equal to, that is 2, that is here, that will go to numerator, that nothing but 2 into Wb RT divided by pi v. WB RT divided by pi v, nothing but what is this WB RT divided by pi v? WB RT divided by pi v is nothing but theoretically calculated molar mass. Okay, what is this MB? This one is nothing but experimentally calculated molar mass. Okay, so experimentally calculated molar mass using colligative property osmotic ratio is twice the normal colligative property. Okay, for benzoic acid, okay, for benzoic acid, experimentally calculated molar mass is equal to twice the normal molar mass. Suppose if any solid undergoes association, okay, any solid undergoes association, then S molar mass is absorbed molar mass is always higher than the normal molar mass. ಈಗ ಕೊಲಿಗೇಟಿವ್ ಪ್ರಾಪರ್ಟಿಯನ್ನು ಯೂಸ್ ಮಾಡಿಕೊಂಡು ಮೋಲಾರ್ ಮಾಸ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿದ್ರೆ ಯಾವುದಕ್ಕೆ ಸಾಲಿಡ್ಸ್ ಅಂಡರ್ ಗೋಯಿಂಗ್ ಅಸೋಸಿಯೇಷನ್ ಎಕ್ಸ್ಪೆರಿಮೆಂಟಲಿ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ತಿರಲ್ಲ ಮೋಲಾರ್ ಮಾಸ್ ದಟ್ ಇಸ್ ಆಲ್ವೇಸ್ ಹೈಯರ್ ದ್ಯಾನ್ ದಿ ಥಿಯರಿಟಿಕಲ್ ವ್ಯಾಲ್ಯೂ. ನಿಮಗೆ ಥಿಯರಿಟಿಕಲಿ ಮೋಲಾರ್ ಮಾಸ್ 40 ಇದ್ರೆ ಈಗ ಸಾಲಿಡ್ ಅಸೋಸಿಯೇಷನ್ ಆದ್ರೆ ದಟ್ ಥಿಯರಿಟಿಕಲಿ ಕ್ಯಾಲ್ಕುಲೇಟೆಡ್ ದಟ್ ಇಸ್ ನಾರ್ಮಲಿ ಆಲ್ವೇಸ್ ಹೈಯರ್ ದೆನ್ 40. Okay, more than 40 ಸಿಗುತ್ತೆ. Okay, this is in case of association. Okay, in summary we can write, okay, these two formulas only. First one is for sodium chloride, second one is for benzoic acid. That is not common. Okay, ಅರ್ಥ ಆಯ್ತಲ್ಲ. If you take sodium chloride, we are getting 2 molecules, twice half. If you take some other aluminum chloride, we are getting 5 molecules. So that is different. We'll discuss later what is that. Okay, we just generally discuss two examples. First expression for sodium chloride, second expression for that is a benzoic acid. Okay, so in summary we can write, if solute undergoes dissociation, okay, if solute undergoes dissociation, okay, observed molar mass. What is meaning of observed molar mass? That is experimentally calculated molar mass using colligative property. Okay, experimentally which one calculated molecular mass using a colligative property is always lower than the theoretical molar mass. Nothing but, okay, here take normal. Okay, normal molar mass is nothing but theoretical molar mass. Okay, theoretical molar mass. Here in case of solids undergoing dissociation, observed molar mass, that is molar mass calculated using experimental method, okay, that's always lower than the normal molar mass. Okay, then in case of if solids undergo association, okay, like benzoic acid, okay, observed molar mass, that is experimentally calculated molar mass using colligative property is always higher than the normal molar mass. Okay, it's always higher than the normal molar mass. Okay, clear? That is in case of, that is the account of association or dissociation. Okay, this which one, higher molar mass or lower molar mass, when you are getting right while calculating molar mass using colligative property, that value is called abnormal molar mass. Okay, ನೀವು ಎಕ್ಸ್ಪೆರಿಮೆಂಟಲಿ ಕೊಲಿಗೇಟಿವ್ ಪ್ರಾಪರ್ಟಿಯನ್ನು ಯೂಸ್ ಮಾಡಿಕೊಂಡು ಮೋಲಾರ್ ಮಾಸ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿದ್ರೆ ನಿಮ್ಮ ಮೋಲಾರ್ ಮಾಸಿನ ವ್ಯಾಲ್ಯೂ ನಾರ್ಮಲ್ ಮೋಲಾರ್ ಮಾಸ್ ಅಂದ್ರೆ ಥಿಯರಿಟಿಕಲ್ ಇರುವ ಮೋಲಾರ್ ಮಾಸ್ ಗಿಂತ ಜಾಸ್ತಿ ಬರ್ತದೆ ಅಥವಾ ಕಡಿಮೆ ಬರ್ತದೆ. ಆ ಜಾಸ್ತಿ ಅಥವಾ ಕಡಿಮೆ ಬರ್ತದಲ್ಲ ಅದನ್ನು ಅಬ್ನಾರ್ಮಲ್ ಮೋಲಾರ್ ಮಾಸ್ ಅಂತ ಹೇಳೋದು. ಓಕೆ, ವಾಂಟ್ ಆಫ್ ಫ್ಯಾಕ್ಟರ್. ಓಕೆ, ವಾಂಟ್ ಆಫ್ ಫ್ಯಾಕ್ಟರ್, ಸ್ಮಾಲ್ ಲೆಟರ್ ಐ. ಓಕೆ, ಸ್ಮಾಲ್ ಲೆಟರ್ ಐ, want of factor. Okay, want of factor. Okay, this is a term used to calculate the extent of association or extent of dissociation of the solute. Okay, then, okay, it is the ratio of normal molar mass to It is the ratio of normal molar mass to abnormal molar mass. Okay. It is the ratio of normal molar mass to abnormal molar mass. Okay. Abnormal molar mass. Okay. Yes. Is the definition of I. Okay. Nothing but simple ratio of normal molar mass andreno. That is a theoretical value. Theoretical molar mass. Abnormal molar mass andreno. Experimentally calculated molar mass by using colligative properties. Okay. So we can write expression I equal to, okay, Vanta factor I equal to normal molar mass divided by abnormal molar mass. Normal molar mass divided by abnormal molar mass. ಇಲ್ಲಿ confusion ಆಗ್ಲಿಕ್ಕಿಲ್ಲ. Normal means what? Theoretical, okay? Theoretical molar mass. Abnormal means what? Experimentally calculated molar mass, okay? Experimentally calculated mass. Then you know, this molar mass and colligative properties are inversely proportional to each other. Then in terms of colligative, we can write that is I equal to observed colligative property divided by normal colligative property. ಉಲ್ಟಾ ಆಗ್ಬೇಕು colligative property ಬರುವಾಗ molar mass and this colligative properties are inversely proportional to each other. ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ observed ಅಂದ್ರೆ ಏನು experimentally calculated colligative property. Here normal colligative property means what? Theoretical colligative property, that is by assuming solid that will not undergo association or dissociation. Okay, the ulta ಯಾಕೆ ಗೊತ್ತಲ್ಲ, already discussed molar mass and colligative properties are inversely proportional to each other. Okay, or we can write I equal to, okay, number of particles, okay, that is number of particles after association or dissociation, number of particles before association or after dissociation, after association or dissociation, divided by number of particles before association or dissociation. Okay, this is the definition of Van factor. Okay, we can write any definition. That is 2 mark question. Okay, what is Van factor? Give its expression. Okay, Van factor is nothing but ratio of normal molar mass to abnormal molar mass. Okay, if molar mass is given, we can calculate I by using normal molar mass, that is a theoretical molar mass divided by experimentally calculated molar mass. Okay, then if colligative property is given, then we can calculate I by using observed colligative property, that is experimentally colligative property divided by normal colligative property, nothing but theoretical colligative property. Or number of particles given, that is a simple method to calculate I. Okay, so I equal to number of particles after association or dissociation divided by number of particles before association or dissociation. Okay, if you take sodium chloride, how to calculate I? Simple example. Okay, sodium chloride, that will dissociate to form Na plus plus Cl minus, right? I equal to number of particles before after dissociation, how much? 1 plus 1, 2. Number of particles before dissociation, how much? 1. So I equal to 2 for sodium chloride. That is how to calculate Van factor I.